Hello everyone, thank you so much for being here. My name is Saad Tariq and I currently work at the Office of Career Services. Today we have with us Karine Frederic Laurier, who's the Associate Dean of Career Services. Karine, I'll give you a few minutes to introduce yourself, say some nice things about NYU and the program, and then we'll move forward.
Thank you so much, Saad, for the introduction. And Debolina, thank you for including me in your event today. Nice to meet those of you that I don't know here yet. And so as Saad mentioned, I'm the Associate Dean of Career Services at Tandon, and we started partnering last summer, started having conversations with STEM-Away in last spring after COVID became a reality for us. And STEM-Away has just come together to propose an amazing array of projects, of opportunities to students, offering it to so many students at Tandon and other schools, other colleges and universities. The feedback we had from Tandon students who did the program was simply fantastic. It was informal emails we received thanking us for putting them in touch with you, Debolina, and your team. Overwhelmingly positive.
Thank you so much for your kind words, Karen. Now I'm gonna move the conversation to Debolina, who's the founder of the STEM-Away program and the person who initiated all these opportunities for everyone during the pandemic. So Debolina, do you have a few words to say for everyone?
Absolutely. But first of all, thank you, Karen, and thank you, Saad. It was my pleasure to get to know quite a few remarkable students from NYU this summer. In fact, working with students is the highlight for me for STEM-Away. So my life as founder of STEM-Away is very different from my previous life. My background is in tech. I was a hardware engineer at Intel. My passion is for zeros and ones, data patterns, and I hold several patents related to microprocessors. But coming back to STEM-Away, the STEM-Away Virtual Internship Program is a very unique program in terms of both project content as well as project structure. So coming back to the project structure, it's just like a mentor chain. It's literally a mentor chain. So we have industry mentors mentoring the leads. We had some excellent leads from NYU, and they in turn were leading student teams. And by doing this, we are able to provide the opportunities at scale. And by being in a lead position, you're building, students are getting this chance to build leadership skills, mentoring skills. And this is what will really help you in your careers, not just getting that first job. We are a full-scale career hub. So there's a hiring portal that is attached to the virtual internship program, which is going live early next summer. But STEM-Away is really not just about your job, but about your career. And what we want from our students is we want to give our students the chance to really get satisfaction from the career they choose. Over to you, Seth.
Perfect. Thank you so much for explaining the program, Debolina. And we'll see along the course of the presentations how everything she said is reflected in our work as well, how we took the lead, how we took the initiative to finish our projects. And now we're gonna move towards our guest, Mr. Prateek Sarkar, who's an ML engineer at Google currently. He works on how people comprehend visual content and works in helping the world's visual information be transcribed into a way where people can use it all across the world and be universally accessible. He currently lives in Bay Area, and according to him, he lives with his wife and moderately cute children. I did not use those words. So we're gonna, Prateek, do you have a few things to say for us?
Thank you so much for having me here. The very first time that Debolina talked to me about this idea that I really want to do something to enable people to learn what STEM is really about and to essentially have this mentoring be part of their training automatically. Her vision and her, I should say, her sort of quiet conviction is really inspiring. So I'm really happy to be here. I look forward to hearing about everything that you have to say. Let me sort of share a few things that I wrote down today. I hope that this is going to be something that all of you share because you are all in STEM. So I wanted to talk about why I am in STEM. So the short answer is because that is a bucket people put me in. That is why I'm in STEM. And let me elaborate a little more why I say that. What did I get? What did I do to get to STEM? It was very simple, actually. I just found fun in elegantly posed puzzles and problems. That is how I got to STEM. And I'll go through some examples. Maybe you'll remember some of these from your own school and college days. You must have heard the story of this teacher who wanted to take a break or take a nap and asked the students to add up all the numbers from 1 to 1,000 or 1 to 100. Different stories go different way. All the students started getting busy at work. One guy stared at the problem for a little while, saw that he could just reverse the sequence and then form these groups that gave him 1,000 and ones, and there, voila, he had the answer. This is so beautiful, so elegant. This is the kind of thing that got me into what we think of as STEM. Here's another example. This is in physics, where we are trying to model phenomena in the real world. And this actually is to some extent attributed to the same guy who found that solution, Carl Friedrich Gauss. So there's this Gauss law for gravity and gravitational fields. But let me tell you the problem. So suppose you are in a planet, not on a planet, inside a planet, a hollow planet. So this is a perfectly spherical planet. Look at how the posing of the problem is making simplifying assumptions to make the problem approachable. You are in a hollow, perfectly spherical planet with uniformly distributed crust. So uniform density of the crust. Inside this planet, how would you go about figuring out how much you would be pulled by gravity and in what direction? It turns out that inside this hollow planet, you would have zero gravity. And it took me a few days when I first tried. I really made sure that I didn't look at any books. I didn't talk to anybody. I wanted to do it for myself. And when I finally proved that it was going to be zero gravity, that was a discovery that I sort of patted myself on the back and I really enjoyed. And I sort of decided that I was going to learn more about these. And then, of course, I found that Gauss had stated it so beautifully in terms of this law of gravitational flux. I'm not going to go into details of that. If you don't remember, you could look it up for homework. Here is another example. This one I heard from the late Professor Thomas Cover here at Stanford. Very simply stated problem. A 6-foot-tall high jumper can clear 6 feet on Earth. Goes to the moon, where gravity is 1/6 of what it is on Earth. How high can he jump on the moon? And you might think that, oh, it must be 6 feet by 6 feet since mgh is the potential and that's linear in height. But no, that's not the case. You are neglecting over there. You might have been thinking of everything as little fleas or point masses, but people actually have a weight distribution over their body, over the 6 feet. So the center of gravity is somewhere at around 3 feet. When he clears 6 feet, he has lifted his center of gravity by about 3 feet. So the gain that he's going to have is 3 times 6, not 6 times 6. But the beauty over here is that once we went from a gravitational field, which follows the inverse square law, to simplifying it and approximate it for near planar surfaces, where the potential is linear in height. From there, you can easily form this concept of center of gravity, one single point at which your entire mass can be concentrated. And if you make that assumption, you're going to be able to solve so many difficult problems with such ease. That is what STEM is about. I wanted to sort of show a few other fun examples. So I got my son to be a model for this. You can find the center of gravity of any stick by putting your fingers resting the stick on your fingers and slowly moving the fingers closer to each other. Where they meet, that's the center of gravity of the stick. It turns out that this works for any kind of stick. It doesn't have to be uniformly distributed mass over the stick. In this case, it's a bow for a violin, which has ununiformly distributed mass. It's heavier on one end. I can still find the center of mass that way. And this has to do with the way we learn, we found out about how the laws of friction work. Here's another one. You might know that if you line up a set of nearly identical balls and you strike that line with one ball from one side, exactly one ball goes out the other end. If you strike with two balls, exactly two balls go out the other end. If you strike with four balls, exactly four balls go out the other end. And it turns out that it's really beautiful. The constraints are conservation of momentum and conservation of kinetic energy. And once you have these two, you end up with a set of quadratic equations. It can have two solutions. One solution was the input state. And by symmetry, the output state has to be near identical. So a new problem. Suppose you have a foot rule, which is unmarked. Right? It's just the length of 1 foot. And I give you this foot rule. Can you accurately measure the height of a person with this? How accurately can you measure the height of a person with this? It turns out that you can measure the height to arbitrary precision. What do you need to do? Start off with a random point on the body and mark out points 1 foot apart as long as the points are still in the body. Now count how many points fit. If you're just above 4 feet, then in some cases you're going to get 4 points. In some cases you're going to get 5 points. You average this out, that is going to be a pretty accurate estimate of the height of a person. So this, I came across the formulation of this problem because I was studying how scanners work. And I extended this to 2 dimensions and came to this concept of a modulo grid diagram, which I won't get to today, but you can follow it up. There are lots of unsolved problems still over there, but it's beautiful. Even these patterns are beautiful to look at. Many of you are applying machine learning for real world problems. OCR has been one of the classical machine learning problems. Now you're applying it to much more complicated stuff like natural language understanding. But I did quite a bit of work on OCR towards the tail end of OCR research. If you find a character like this could be either a 1 or a 7, right? However, if you see that next to that character next to this is clearly a 7. The other one must be a 1. However, if you see that character next to it, that was really a 1. This new character is what a 7 looks like. And different people have different writing styles. And these styles induce statistical dependence amongst the different patterns that you produce. And I studied this, and this was called it style consistency in isogenous patterns. I have to tell you a little bit about what I do now. I've been telling you about all kinds of fun that I've had throughout my life. I work in Google image search. So in image search, if you search for, say, a flower vase, we give you lots of beautiful pictures of flower vases. You can scroll through these, look at these beautiful pictures. Our goal, our mission is to make the world's information, visual information, universally accessible to all, and make it visually navigable. What does that mean? Out of all of these results, if you clicked on one particular result, that is the first visual cue that we have about what you might be interested in. And we have this feature called related images. If you're not familiar with this, you can give it a try. And if you find bugs, please do file bugs. There's a button right on top, and we actually have people who scour through bugs filed by users. But our objective is to give you a chance to navigate through this world visually. You didn't have to know what kind of terms to use to describe this middle image, but when you liked it, we can show you other images like that. Perhaps you'll even learn what kind of a flower vase that is by just exploring. So that's the thing. So what did I do to get here? And here I'm going to start digging into my Indian roots and start using flowery language, because why not? Yeah, you know. So the language is this: centuries of masters created disciplines of thought and turned them into playgrounds, beautifully manicured playgrounds with beautiful rules and beautiful pathways, very elegant designs, and adorned them with fun problems and puzzles. That's what attracted me in. So I went in to those playgrounds to have fun. And in the process, I learned a few life lessons: curiosity, rigor and perseverance, self-critique, a love of elegance, simplicity, clarity, and structure. These are all that came out from that training that was laid out for me by the greats who discovered these spaces, but also my teachers. So the last important point is the ability to take a complex problem and simplify it and to find a structure of a solution. And that is where the role of a mentor comes in. As I progressed through my career, I faced more and more difficult, open-ended problems, not well-defined, neat problems that I could apply laws to. But it was now my job to try and find discipline in there, simplifying assumptions in there to make the problems tractable. So why am I'm in STEM? Because that's the bucket my work fits in. I would have taken these life learnings. I actually do take these life learnings everywhere. Even when I practice music, I apply these same things. That is just part of who I am. But my STEM employer finds value in my bringing these traits to problem solving. That's why I'm in STEM.
And I think it's communal, the love for problem solving within the STEM field and the STEM disciplines. I have two of my teammates here. We are going to move into the project definition, the problem statement, and how we thought we were going to deal with that, the architecture that we used, the project execution in terms of the steps, exact steps chronologically we took to execute this project, our comments on what could be possible future work for the product that we made, and then we'll open the floor for some questions and answers at the end of it. The problem that was given to us at the start of the project was, it was open-ended, and what we knew was that we want to improve the tagging that exists on the STEM-Away forum. So if you can see here on the right, this is the mechanism, or this is the interface when you make a new topic or new comment at the forum. This is the interface that you have to deal with. And we identified three major problems with the current system that was in place for the tagging. The first one was that there is no algorithm, or the algorithm is very inefficient. Hence, being said, the interface does not encourage tagging. There are no recommended tags for the users over here. And the last problem that we identified was that the new user fed tags or the new user comments, they are not used to improve any model or any system, which we think is key, because STEM-Away is it's already exploding with new comments and self-assessments and topic titles coming in every day. And we feel like we should use that new information to keep improving our models.
The first thing we needed for the project was to actually get some data which we can train our models on. So as a group, we chose to scrape our data from the Stack Exchange forum. This decision was made from a few considerations of factors. They have tags that are relevant for each post. And adding on to that, there is a voting system on the platform, which further gives these posts and its tags extra credibility and tells us that it is indeed relevant. As a group, we managed to scrape a total of 60,000 data points from the forum. And from those 60,000 data points, we obtained 480 unique tags that were related to machine learning. We chose to reduce the number of tags we would like to predict from 480 down to 25. And these 25 tags were chosen based on the frequency that they appeared on the forum, and also the relevance of each of these tags to the post that we would normally see on the STEM-Away forum.
So now that we had built the backend model, and in order to scale it for any real world application like LinkedIn or any forum that has a huge number of posts, it is not always possible from our end in order to throw a recommender and to predict for unknown category post as well. You can see that architecture here. In the right side of architecture, you can see active learning loop, where we show the predictions out of which the user will be annotating them, and that will be sent back into our model where we retrain it. But how efficient is it to retrain it for every new input? Is it possible for a real world scenario? No, I don't think so, because we have a lot of social media or any forum websites that have tons and tons of posts, and for every new post, if we want to retrain our model, that would be super inefficient. We thought of creating a UI for it in order to show it to user. Instead of talking about the programming part, we would like to make sure that it is like a product which can be usable. So we try to deploy it into Streamlight and make it into a user friendly thing in order to make sure that user can see it, what is actually happening there.
So talking something about design thinking process, so it consists of basically 5 major steps: empathize, define, ideate, prototype, and test. So empathize is where you learn about your audiences. Define is you come up with a problem statement. Ideate is when you are actually familiar with the problem statement, you try to come up with the creative solutions. Then the next step comes as prototype. So here's the two type of things: low prototyping and high prototyping. And then the final step is testing. So when you actually test your product before just coming up or giving it to the market. So in this slide, you can see the empathy map that my team designed. So this empathy map was created considering the STEM-Away and what the users think about it. So here's the look for what my team did. Talking about the user research interviews, so I just want to talk one important thing here, as this is like very important step of our part or the process, because we interact with the users, we talk to them related how they feel about the site, what problems they feel when they first visit this time away, what changes they think they should make it. So this was a very important stage, and it really helped us in drafting how should we designing our low fidelity and high fidelity prototyping. So we got some positive, negative feedbacks, and we used that, and it really helped us for displaying the relevant information to new visitors and reoccurring participants.
So as Saloni talked about her experience as a mentor chains lead and leading the user experience and user interface team, I was a user experience lead as well, along with her for another team. But at the same time, some of the leads were also working on another project at STEM-Away. So here are 4 of us. It's me, Anthony, it's Fiona, and Pooja. 4 of us were working on creating the user interface of a corporate dashboard for STEM-Away. So moving on to what my team designed, not my team, but all of us designed is, you can see on the left hand side, there are technical skills that you're looking for a UX UI designer, skills like visual design, high fidelity prototyping, information architecture, and then you can put in the importance of that skill, what level of importance are you looking for that particular skill. Similarly for soft skills, and then on the right side you can see that there is a map, and then there are locations where you're looking for UX and UI designers. Moving on to the next slide, we'll be able to see what the final version actually looks like. So here we can see the page for the technical skills. This looks much more neat. This looks much more efficient and easy to use. Now, what was important is the color pattern, maintaining the color palette as well. When you're working with visuals, when you're working with graphics, it's important to make sure that the user is kind of connecting well with what the company has to provide. So we're choosing kind of shades of green over here, and that is something that we're highlighting in this page as well. And then there's once again an active panel and a result panel on the right side. The active panel meaning the panel where you can prioritize technical skills, soft skills, and then on the right side, there's the result panel.
It's actually really great to hear all of this energy and enthusiasm, and that is grounded in actual experience. So I'm really excited for what STEM-Away is going to continue to do. I have been actually blown away by some of these presentations to think that these were put together in the space of a couple of months or 3 months by people who are claiming that they didn't have any background in some of the necessary fields, some of the things that they had to work with. So this was really amazing. So I individually, I found each of the speakers to be so articulate. Even at the end, when you're talking about these open-ended experiences, you're very, very articulate. And even with the slides, you're very articulate. I feel like I should come and get some real-life training from STEM-Away. This is great. And for the UX part, I actually had one high-level question that I would have liked to ask both Jay and Saloni.
Yeah, sure.
Is UX often focuses very much on the tools. By the way, UX research and UX design both have reached a level of excellence now that wasn't there 15, 20 years back. A lot of people were talking about UX research as an HCI, but today, I mean, I used to work at a place where UX research was really taken seriously, and there were anthropologists who used to work amongst us who would try to understand how users interface with technology, what to do, what not to do in the very big picture of things. One thing about STEM is that you can work fast and furious on a project, but you come out of that project with ideas and knowledge of the problems that you don't actually have to work fast and furious on, but those should keep on working in the back of your mind, and you'll interact with many different kinds of people that get exposed to many different kinds of ideas, and maybe 5 years down the lane, you're going to come up with an idea that sort of says that, oh, this is a problem that we weren't able to address at that point of time. Maybe this new field that I'm just learning about provides some opportunity for interdisciplinary work where we don't have to develop anything fast, but we can start developing something new. All of these side skills, which, sometimes they're not very exciting. The fact that you have to document and the fact that you have to interact with all of these people who don't think like you, it's sometimes very taxing, right? You wish that people would just think like you, but then to realize the strength in all of these things later on, that's definitely been one of the learnings of my professional life. Thank you very much, Debolina, for having me. We'll touch base again soon. This was really an interesting afternoon. Time very well spent.